Now we will see again what are the different types of semiconductor. Yeah, so definitely again we are just going to say for this particular case, let's say and just show that there are different types of semiconductor. One is nothing but intrinsic and another is nothing but extrinsic. Now we know that, so that germanium or silicon, there are 4 electron in its outermost shell, that is a valence shell, and 4 of which he just share with the neighboring, so its octet is complete. Yeah, and definitely then we can say that it is a stable one. So now in case of intrinsic, that is what we can call it as a pure semiconductor, like that is a 24 karat gold, it is a pure one. Yeah, but then 22 karat obviously it is not pure, we are just adding some impurity in that. So similar to that, so this semiconductor intrinsic, it is a pure form. Yeah, so the number of, now how those electrons and holes are generated over here. So the same thing, so I just consider that, so this is, let's say, valence band, and then this is nothing but your conduction band. So again those bonds are there which are already formed, and that breaking of those bonds will result into the vacancy of your holes. Yeah, so one of the electron from that valence band will jump over here, it will came over here, and this is now your holes has been created. So likewise I have shown 3 holes, and corresponding to that I have shown 3 electrons. So there are electrons and hole pairs. So what you can say that, so there are electron hole pair has been created for this particular case. Yeah, and this is what we can show over here also. So but the thing is that the number of electron hole pairs which has been generated over here are very few, they are actually very less. Yeah, and which we can't use in any practical application for the same time. So then because of that, what we are going to do over here, so this is how we can show, this is a germanium, then this is how we can show the bonding between them. Yeah, so now its octet gets complete over here. Okay, so now I just provide some heat energy, so you can say that there is a loss of one of the electron, it just travel into the conduction, and there is one hole has been created. Yeah, so this is how we can show it over here also. So they are just moving over here from one point to the another point. So this is the valence band and conduction band, and the amount of energy that you need to supply, yeah, so that the bond gets break and it will enter from that valence to conduction. So that is what we can call as a forbidden energy gap. So this is how we can show that. See, you can see, so this is your valence electron, yeah, and this is the covalent bond, this is broken covalent bond. So this becomes free electrons, and those black one are nothing but holes. Yeah, so now what do you mean by doping? So doping means you have to add some impurity in that. So that concept, we are just deliberately adding a small amount of impurity. So you are adding that water in that pure milk, so the quantity will get increased. Yeah, that means a kind of doping, what we can say over there also. Yeah, so now the same thing we are going to do for the semiconductor also. So that semiconductor containing that impurity is known as a impure or extrinsic semiconductor. That means you are just modifying now its property, you are adding some impurity in that. So that is called as a doping of semiconductor. So now there are various methods of doping: heating the crystal in the presence of dopant atom, then adding impurity atoms in the molten state of semiconductor, or bombarding semiconductor by ions of impurity atoms. Yeah, so this is how it will take place. Now again that extrinsic semiconductor is divided into 2 types. One is your N-type semiconductor, another is P-type semiconductor. Now if we just consider that your N-type semiconductor, so you have to dope that semiconductor, that pure semiconductor, with the impurity, with the element from the group 5th. Yeah, so let's say that is for example phosphorus, yeah, arsenic, Sb. Yeah, so now what is the property of your group 5? So there are 5 electrons in its outermost shell. Yeah, so the one which I have shown over here for that As, yeah, so it is having your 5, definitely you can say that. Yeah, so that is how we can just show for this your N-type semiconductor over here. So what will happen over here? So the group 5 element that 5 electrons, so it share its 4 electron with the neighboring, that your germanium or silicon, but after sharing 4 still there is 1 electron which has been left. Yeah, so now how you are just going to show it over here also. So let's say this is the free electron now which I have just shown for this particular case. Now likewise there are large number of free electrons now available for the conduction. Since this is a free electron, so you just need to provide a small amount of energy, it will become free. Yeah, so likewise now the large number of free electrons are available. So because of which you can say that the current mainly flows because of this your free electrons. So the majority of carriers, that is nothing but electrons. So we just seen that the two kinds of current, one is nothing but obviously what we will say over here is nothing but your hole, the current that is a contributed because of hole and the current contributed because of your electrons. So that like that, so we can say that, so this is the majority carrier is nothing but electrons. So you have to just dope with that group 5 elements, so which is having the 5 electrons, out of which 4 he will just share with the silicon or germanium, still 1 is left, so that is almost a free. So likewise you are adding the impurity, so large number of free electrons now are available, so which makes sure that, so obviously there is a possibility of flow of current in the n type semiconductor. And the same thing which we have shown, that is a valence band and conduction band. Now since it is denoting that or donating 1 electron, so this is called as a donor. Yeah, or this is obviously we call as a donor level. Yeah, so this is the impurity atom is called as a donor. So n type semiconductor also called as a donor type semiconductor. Now similarly we have to study the p type semiconductor. So where you have to just dope that semiconductor with the group 3rd element indium, that is nothing but, let's say for example, so there are only 3 electrons. So when there are 3 electrons, he just share its 3 electron with the neighboring germanium, so that germanium having the 4 electron in its outermost shell. So indium will just share its 3, but still now there is a vacancy. So definitely you can say that. So there is a one vacancy over here. So let's say when I am saying that it is a vacancy over there, so that means another electron can fill this your vacancy. So the bond will might get break somewhere else. Yeah, and that electron will come over here. So the holes now get shifted to this. Yeah, so likewise the hole is getting continuously shifted in a particular direction, which constitute of your the current, that is mainly because of your hole. So the majority of carrier for this your p type semiconductor, that are nothing but your holes, and this is called as a acceptor. So definitely this is what we are calling as a acceptor type semiconductor. So the majority of carrier in this case, they are nothing but the holes.